Okay, welcome back. Um, we have a question on molecular reactions. Application to ordinary differential equations. We have a question like suppose that one molecule of A combines with one molecule of B to form one molecule of C. Okay. So the reaction can just be modeled by this. The reaction implies A plus B goes to C. Okay, one molecule of this, one molecule of that. Assume that at the outset the concentration of A and B are 2 moles per liter and that of C is 0. Okay, so we can let A, B and C be the respective concentrations of A, B and C. Okay, these are substances and these are their concentrations. Okay. So right now, since we require 1 mole of A of substance A to form substance C, then this will imply that and at the outset the concentrations of A and B forms 2 moles per liter. So we require 1 mole of A to form 2 moles per liter. So the concentrations of A is 2 mole per liter each. Okay, are 2 moles per liter. Each of them is 2 mole per liter. So this will imply that we will now have okay. So we are saying that let A, B, C be the concentrations of the respective substances A, B, and C. Okay, and so we from the problem we know that the concentration at the outset of A and B are 2 moles each. Okay, so this will imply that A is equals to 2 and B is equals to 2, all of that at the outset. Okay, now since the formation of 1 mole of C requires since the formation of 1 mole per liter of C requires the combination of 1 mole per liter of A, then this will imply that we will now have 2 minus C for the A and 2 minus C for the B. Okay, because we need 1 mole per liter. So since, just like I was saying, since the formation of 1 mole per liter of C requires that we use 1 mole per liter of A, then the concentration of A after t seconds will just be this, and the concentration of B after t seconds will also be this. I hope you get that. Now, by the law of mass action, the differential equation implies dc dt equals to k brackets 2 minus c another 2 minus c, like this. Okay, and now using the IVP, so we now have our IVP to be the C, the T to be equals to K, 2 minus C, another 2 minus C. Now C of 0 was equals to 0. That's what they said at the outset. C was 0, and that of C is 0 here. Okay, assume that at the outset the concentration of A and B are 2 moles per liter, and that of C is 0. So the concentration of C is 0. Now then after 1 second something started happening. Okay, so we have this which we can solve. So let's try and solve this particular question. We have the C, the T equals to K, 2 minus C, 2 minus C, and then this one is separable, which you can separate. Have the C, 2 minus C squared equals to K dt. You remember this and this are 2, so multiplying them will give you just this 2 minus this squared. Okay, so right now we can integrate this, but how do we integrate this? And so integrating this, the integration of this one will just be integrating this one to, that will just be K. Okay. So this D is a constant of integration this time round. Okay, so let's see. So here like this, I can find my D using the IVP over there. Okay, so they said C of 0 equals to 0. So this will imply that 1 over 2 minus 0 equals to K of 0 plus D, and this will imply that we have 1 over 2 equals to C. Okay, so therefore we will have 1 over 2 minus C equals to KT plus 1 over 2. But the LCM here is 2. Is it 2? No, not exactly 2. I just want to, okay, let me do this. 1 over 2 minus C equals to this part will be 2 KT plus 1 all over 2, and this one I can do cross multiplication, and so I have 2 equal to 2 minus C, 2 KT plus 1, and so I just want to make C the subject. This equals to 4 KT plus 2 minus 2 CKT minus C, and so I have 2, this and this will go, yeah, so I'll just have this, so I'll have 4 negative 4 KT negative 4 KT equals to C into brackets 2 KT minus 1. This is also negative, so I just divide here. Negative 2 KT minus 1, negative 2 KT minus 1, this and this will go. So I have my C to be equals to 4 KT all over 2 KT plus 1, like this. So right now but they said after 1 second C is equals to something. After 1 second, after 1 second, the concentration is this per liter. Find a formula for the concentration. Okay, so C is equals to 0.2. So that's what we are going to do. So right now we have C of 1 equals to 4 K of 1 all over 2K of 1 plus 1 equals to 0.2. So this will imply we have 4K equals to 0.2. So we have 0.2 times 2. So we have 0.4 K plus 0.2 like this. So this will imply that we have 4K minus 0.4 K equals to 0.2, and then we have 4 minus 0.2, sorry, 0.4, 3.6 K equals to 0.2, and then this implies we have K to be equals to 0.2 over 3.6. Let me see, 0.2 divided by 3.6. So this is equals to 1 over 18. That is your K. That is your K. So therefore, we now have C to be equals to 4 1 over 18 T all over 2 1 over 18 T plus 1. Okay. Yeah, I think so. So this one will become 9 2 here, 9, so 2 over 9T all over sorry, not 2, okay, 2 here, okay, 1 over 9T plus 1. Okay, so let's see, they are saying that how long does it take for the concentration of C to reach 1 mole per liter? Okay, find the formula for the concentration of this, and how long does it take to reach 1 mole per liter? Okay, so we will have to find C at 1 mole per liter. So at what time will C equals to 1? So that simply means that this implies I have 2 over 9T all over 1 over 9T plus 1 equals to 1, which will imply that we have 2 over 9T equals to 1 over 9T plus 1. And so we have 2 over 9T minus 1 over 9T equals to 1. This implies that we have 1 over 9T equals to 1. This is over 1, so this implies that T is equals to what? 9 seconds. Okay, and so this is our final answer. So at 9 seconds, therefore at T equals to 9 seconds, C is equals to 1. That's our conclusion. Thank you for watching. Kindly subscribe.